In episode 78 of Mobycast, we introduced the AWS Well-Architected Framework, an indispensable resource of best practices when running workloads in the cloud. We explained that the framework defines 5 pillars of excellence, and we dug deep on the first pillar, operational excellence. If you missed that episode, you can hit pause, and we'll wait here while you catch up. Now, in this episode of Mobycast, Jon and Chris continue their 3-part series on the AWS Well-Architected Framework and discuss the next 2 pillars of excellence, security and reliability. Welcome to Mobycast, a show about the techniques and technologies used by the best cloud-native software teams. Each week, your hosts Jon Christensen and Chris Hickman pick a software concept and dive deep to figure it out.
Welcome, Chris. It's another episode of Mobycast.
Hey, Jon. Good to be back.
Yeah, good to have you back. So again, without Rich, another week goes by. We're missing the man. He should be back soon. We are still in the middle of just the depths of learning about software architecture. And there is so much here, so much to learn that we can't get it all done in a quick 40-minute conversation. So 2 weeks ago, we started this off with a 12-factor app. And that was pretty easy and digestible. And it was just like, here's some things you do with an app to make sure that it's pretty good. And you can deploy it onto like a platform as a service. And it works well and is pretty reliable. Then last week, we got into the real hardcore stuff. We started doing the Well-Architected Framework from AWS, which is just a beast. It is just like, here's everything you need to know and do if you're going to run distributed systems that are capable of serving millions and millions of people and have, umpteen nines worth of uptime. And there are 5 pillars. And last week we got through, there's 5 pillars and there's also, some general design principles and just like the introduction of the whole thing. So last week we talked about just the whole thing and what it is and some of the general design principles. And then we talked about the first pillar, which was operational excellence. This week, we're going to talk about 2 more pillars, security and reliability. And I'm excited. I think that we've noticed that not everybody that listens to Mobycast loves our episodes about security, so we'll keep that tight. And we might not even put it in the title. But we do have to talk about it. It's pretty important. So we'll talk about security and reliability. Chris, you want to kind of kick those off for us? And any kind of, talking about stuff we talked about before, too, is welcome.
Sure. Yeah. I mean, you set it up perfectly. So we're just going to roll right into it here with the second pillar being security. And, there's a lot here. Security is extremely important. Just there are breaches every day. And these are really expensive, right? They cost millions and millions and millions of dollars, across the board. So security, we always kind of laugh at it a little bit, like, no one likes to talk about it, no one likes to do it, but it's so important. And I think the great news here is that there are so many tools and services that make it so much easier. Like, it doesn't have to be a really big thing, right? You can actually get a big area of coverage with security with not a lot of effort, right? But you just have to make that commitment to actually include it, right? And so that's one of the reasons why it's here, right? It's one of the pillars. I mean, I remember the first time that you were looking at the Well-Architected Framework, and you were like, scalability, like that should be a pillar, right? It's like, right, yeah. But it's not, right? So instead, it's in reliability is really kind of where that is, but security is so important, it gets its own pillar. Right?
Yes, and security is the high fiber diet of software engineering. Like, you definitely want to, do the things that are not the best tasting in order to have good results.
Yep, indeed. So let's dive into it. So, security pillar, they define it as security. It's the ability to protect information, systems, and assets while delivering business value through risk assessments and mitigation strategies, right? So this is all about...
That's a mouthful. That is a mouthful.
Yeah. But so the important thing here is just, it's I think it's risk assessments, right? So knowing what's where you have risk areas, and then developing your mitigation strategies, right? So
let's talk about the first three things too, though. Like, why bother separating out information, systems, and assets? Like, what are those three things? I guess data, that's maybe in databases. Systems are like computers or running software, maybe. Yeah, running software is what I would think of as systems. And then assets would be the actual computers or load balancers or physical devices kind of thing. Or maybe, yeah, I guess that's probably what they're talking about when they're talking about assets. I guess I was also thinking, assets could be like video files or something. Like, those could be assets. Because it's a weird, it's one of those words that it means one thing in one situation and another in another. Like, if you look at your Node.js directory and there's a thing called assets in it, that's going to be your images and your, and your HTML, your images, your videos, and just things like that, GIFs, whatever. But this is not that kind of assets. This is like business assets, I would guess.
Yeah, this is kind of like the general, description, of what it is. We'll get into this with the focus areas, and this will become definitely a bit more clear on, what it is that needs to be protected, right? But
yeah, I guess I interrupted and wondered, because it's like, well, if this is so carefully worded, then those three things must be the things. There must not be anything else or whatever. But it could just be, a writer did this and those came out.
Yeah.
Cool.
All right. So let's walk through the design principles for the security pillar.
Before you do, I just want to remind people from last week that sort of every pillar has design principles, it has the focus areas, and it has best practices. And those are the three things we talked about. Last week, the operational excellence pillar also had a key service. Oh, it looks like security has key services as well. So
for each pillar, we will talk about a key service.
Key service. Okay, cool. So design principles, key service, focus areas, and best practices. So here we go with design principles.
All right. Yeah. So first design principle is we want to implement a very strong identity foundation, right? So it's like, this is kind of core to protection, is just the fact that you can do things like authentication and authorization. So that's the first thing. Second, enable traceability. So being able to see what's happening and what's happened in your system from a security standpoint.
Well, that one's nice, because we talked about that one last week too. So it's like kill two birds with one stone, because you wanted the traceability, like at least like transactional traceability. We talked about that last week, like putting in X-ray or something like that.
Right. Yeah. So that was request traceability, transaction traceability. So this is now traceability from the aspect of security and access.
Okay. So this is more like who's actually touching systems, what IAM accounts are doing things in your AWS account kind of stuff.
Yeah, think about it, like when they do have like these breaches, right? It's not like they don't catch them in the act usually, right? It's like something gives rise where they've realized that, oh no, we've had a breach, and then they have to do the forensics on it, right? So that's when they're going back to things like logs and what other sort of data that they have to do that forensic analysis, right? So that's that traceability part.
Right, and this is for both. I guess I take back one thing I just said. It is for the AWS systems and the IAM roles and accounts and stuff that are touching that, but it's also your application. So any users that are doing things in your application, that should all be traced as well. Like, nobody should be able to change state of your application without sort of being who they are and having that be audited in some way, go into some sort of log somewhere.
Yeah, and this feeds into the next design principle, which is just security at all the layers, right? So, you want security at the data layer, you want it at the infrastructure layer, you want it at the application layer, you want it at the network layer. You just, all the layers, right?
Right.
Yeah.
Cool. I could have written this in myself.
The Well-Architected Framework by Jon Christensen. Yes. Cool. So moving on, the next design principle, automate your security best practices. As we talked about before, like, a huge theme throughout the entire Well-Architected Framework is automate all the things, right? Anything that can be automated, go ahead and make the investment to automate it. So We did that in operational excellence, automate as much as we can of operations. And so the same thing here at security, take your best practices and automate them as much as you can. Another key design principle here is protect your data in transit and at rest. Very topical, coming off of our encryption series of episodes, right, where we talked in depth about encryption and how the difference between doing encryption in transit versus at rest. Another principle is keep people away from data. And really what this is saying is, like, if someone has no need to access data, then don't allow them to, right? So it's the principle of least privilege here applied to the actual data itself. And so this is obviously super important for folks that have regulations that they need to comply to, like maybe a HIPAA or PCI or whatnot, right? So making sure that you're giving least privilege.
I think it's worth telling a quick story about this, because this just came up with one of our clients just the other day. I feel like this is sensitive enough that I should kind of keep who it is and who the third party is to myself, but I'll try to at least explain it. It's like there was a service that would allow people to write messages to each other, direct messages to each other, and that service has a feature that is an extra add-on pay-for feature that allows you to do content moderation. So you could go and see if people are saying bad things to each other and stop that, prevent them or tell them not to or whatever. And as the guiding principle that we were using is, you know what, let's give people the tools to not accept messages from certain people if they want, so to kind of block them or report them. But we don't really want to be in the business of knowing what people say to each other. We just don't want to even know. And so it was like a conscious decision that we were going to absolutely not use those moderation tools. We were not going to buy that feature. We did not want to have access to that feature. It's just like, you don't want to be in the same room as the temptation, right? Like make sure, like, we just didn't want it. Let's have a policy be that the keys are behind locked doors. Only one or two people have access to the keys ever. And if you want to, if there's some reason that some messages need to be decrypted, it better be a legal reason. And it's like, we don't mess around with that stuff. And that was just, I think that's a telling example of that security principle you just mentioned. Like, don't make that data available if it is sensitive data and it could cause harm to people.
Right. Yep. Exactly. All right. And then for design principles to close it out, the last one is to prepare for security events. Right. So this is just, again, kind of knowing like the inevitability, like there's probably going to be some kind of incident. So what's your response going to be to that? And just having that thought out, right? Like how will you do it? And so again, this goes back to risk assessments and mitigation strategies. Yeah.
You call everyone into a room and everyone runs around screaming and shouting, pulling their hair. That would be my plan.
Yeah. Maybe we'll work on that. Right. I think we can do a little bit better than that. Yeah.
Go ahead.
Yeah. So key service. This one's pretty obvious. It's AWS IAM, Identity and Access Management, is definitely going to be key to the security pillar here. IAM is the core, identity foundation for AWS and all its services. It gives you support for users, roles, groups. You can have policies. You can have fine-grained access control. And so definitely this is going to be the foundation for most of the things that we do in the security pillar. Right on.
It does feel like this is a bit of a push, though, from AWS. It's like, yes, of course you need to use IAM for any infrastructural stuff. So you're going to have roles around ECS, or you're going to have roles that end users that can talk to certain EC2 instances, and that all makes sense. Of course you have to have that. But I do feel like AWS, for a while now, and more successfully, is trying to push IAM into your applications themselves. And that's through tools like Cognito and federated identities, where some pool of your users might take on a role, an IAM role, in order to access certain files in S3 or whatever. I just feel like that's the direction AWS wants to go. They want to they want to get IAM into your apps instead of having you own everything about your users and your own databases and application software. It just feels that way to me.
Yeah, I mean, a common theme just with AWS and any one of the cloud providers is they have their core services, and a big part of the value proposition is the synergy that you get and the interoperability and the integration between all those services. And so, IAM is their identity and access management platform that all their services are going to use. So it's going to, the more you use that and leverage that, the easier it's going to be for you to integrate into the system, right? It's kind of like what we talked a little bit about with KMS, with encryption, where, again, KMS is the core service for managing keys and doing things like encryption, and it's very well integrated with all the AWS services. So if you want to make things as easy as possible for you and have that deep integration, then you're going to have to use KMS. Or you should use KMS, as opposed to, they will give, they give you the tools that you can, bring your own, do your own thing. But if you do that, you're going to have some heavy lifting to do.
Mm-hmm. Yeah. And I'd say, today I can imagine doing something where my actual, our application's actual users that are in our user table in some database have some sort of direct affinity to IAM roles in order to be able to access certain things. And maybe some users have a different role than other users. I can really see doing that today. And I would say 5 years ago, it wouldn't have even crossed my mind. Mm-hmm. Cool.
Yep, indeed. All right, so let's rolling on focus areas. So 5 focus areas here for the security pillar. So 1, identity and access management. 2 is detective controls. 3, infrastructure protection. 4 is data protection. And the last one is incident response. And so, these focus areas we can now look back at that original statement of, the ability to protect information systems and assets, right? And so what does it mean by that, by information systems and assets? And so these focus areas kind of give clues to, what we're talking about here. So, one of the focus areas is infrastructure protection. Mm-hmm. And so that is the probably, in this case, it's the assets, and maybe and getting into systems as well. And then we have data protection, which that's going to line up well with the information part of that, of what we're protecting.
Right.
And so those are the two focus areas around like protection with infrastructure and data. And then we have, the core identity and access management as being one of the focus areas. And then we have these detective controls and incident response. And detective controls is basically, those are the things that's allowing this traceability for who's doing what. And then incident response is like, what are we going to do if there is a security event? Like, how do we handle that?
Right. So, and last week I went on a tirade about focus areas because I felt like prepare, operate, evolve are not, like they don't grammatically fit that word. Mm-hmm. But these ones, they feel right to me. These do feel like focus areas of security. So, well done on this one, AWS.
Mm-hmm. Cool. Yeah, wait till we get to reliability. I don't think you're going to be too happy with those focus areas, but we'll get there.
Right on. And today too.
Yeah, and today.
Stand by.
Yes. And then maybe just to call out a little, some of the services, AWS services that will be applicable to each one of these focus areas. So for identity and access management, obviously IAM, that's its reason. I mean, it's actually IAM is identity and access management, right? So it's almost like news, not GNU. And then other things, though, AWS organizations and MFA would definitely be kind of key features and services to be thinking about in that focus area.
Okay.
For detective controls, we'll have things like CloudTrail, CloudWatch.
By the way, there's a notable lack of Cognito on that one. I thought I'd point out.
Only just because it's, that would definitely fall into that for sure. But it's not as common use case, right? Like Cognito is a bit more at the edges for various different workloads. It's only for certain workloads that you're probably going to use Cognito. So, That's why it's not like one of those core services like that we're talking about right now, but absolutely,
Sure.
it falls under that umbrella. So yeah, for detective controls, CloudTrail, CloudWatch, AWS Config, and Guard Duty would be some of those important services to be thinking about. CloudTrail is the capability for logging basically all the API calls being made in the system. And it's going to vary on the service on exactly what's logged as far as the API calls. But once you enable that for your account, you'll get that login and you'll be able to see those events.
I think it's worth saying that when you say all the API calls, that really means everything that happens inside of AWS, because nothing really happens in AWS without an API call. When you're using the console, under the covers, an API call happens. When you're using CloudFormation, under the covers, an API call happens. So, right? Like
it is. The kind of unfortunate thing is that, CloudTrail is not going to log all the API calls. It's only going to, and again, it's on a per service basis. The service is kind of dictating what API calls will get logged to CloudTrail. So as an example, not too long ago, we had a IAM user account set up, and it had a key pair, a secret key, access key, so developer credentials associated with that account. And this had been set up a long time ago. These credentials were being used by some application in the system, and of which there was many, many applications, right? We could see when these credentials were last used, so we knew that they were still being used, but we had no way of seeing who was where this was actually being used, right? And so the hope was, CloudTrail will help here. And,
right.
It turns out with CloudTrail, and it's only going to log the API calls for those credentials on management task, not on actual user action. So the calls for using those credentials to do some operation, that's not going to get logged. And so it was one of those things. It was like, oh man, this kind of feels like perfect. Like CloudTrail really helped here, and turns out it wasn't going to help us at all.
I want to say that there's some kind of irony about the AWS Well-Architected Framework and the security best practices, and AWS itself sort of tripping over that with that example you just gave. But yeah, I'm not sure. There's also, it feels like wiggle room for them to say, no, that's on you. You should have done that.
Yeah. Anyhow, if anyone out there has a better idea for how to figure out what actual application is using a set of developer keys, I'd be open to hearing that, because we tried many different. I was looking. Just anything and everything between CloudTrail and VPC flow logs and just kind of anything and everything, and just not really coming up with anything good to try to figure out who is using this. All right. Infrastructure protection. So that focus area, some key services you can use there are going to be VPC, right? And all the network components that go along with that. So, how you're building out your subnets and your NACLs, security groups, firewalls, right? All that kind of stuff. So AWS Shield is another thing here. So helping you with distributed denial of service events, service attacks, and then WAF, which is
that's what I was thinking.
The web application firewall. Yeah. So some good services there to take advantage of. For data protection, KMS. So we talked about this in length in the encryption series. ELBs, just in the from the respect that ELBs will do TLS for you. So let them, right? So they can do your TLS termination.
Although you don't, I think it's worth pointing out that if you let your ELBs do your TLS termination, then you're not technically all the way end to end with your encryption.
No, you're not.
So
but it's actually really hard to do that.
We had to do it for a client that was had to be HIPAA compliant, and it wasn't sufficient to let SSL or TLS terminate at the ELB. Gosh, that's a mouthful.
Mm-hmm.
Cool. Incident response.
And so some key services there are going to be IAM again and CloudFormation. And so the well-architected framework calls out CloudFormation here, which is a little bit of a head scratcher at first, but really what it is their approach to these kinds of things is to basically build a clean room environment where they can go do the forensic analysis. So CloudFormation comes in here where it allows you to stand up a complete replica of the environment and do the replay and do the forensic analysis like in this clean room, which is, again, pretty sophisticated. Yeah. So those are the key focus areas, and their associated AWS services that are probably going to be you want to keep pretty close by. As far as best practices go, why don't we talk about a few examples of best practices in some of these focus areas? And so one would be in the identity and access management focus area. We could use Cognito. So you mentioned that before. And so this is absolutely, one of those best practices to act as a broker between login providers. And also, if you want to do secure access of any AWS service from a mobile device. And we talked about this in a previous episode where we specifically just talked about Cognito and kind of your experience of building an app that needed to access these AWS services, like I think it was Dynamo, and how it could do that securely. And so Cognito was the answer there, where it's basically creating these user pools that then get mapped to temporary IAM credentials.
Yep, and that was the JavaScript React.js app, so with a node layer and Lambda. So yeah, it's not just mobile. Cognito isn't.
Mm-hmm.
Go ahead.
So in the data protection focus area, some best practices there are definitely just encrypt all the things, right? Mm-hmm. So we want to use encryption at rest. We want to do encryption in transit, and we want to encrypt our backups. Again, we talked about encryption at length, and there's really no reason why you shouldn't. There's no reason not to. So just encrypt all the things. You also want to do for data protection and do things like versioning. So S3 supports versioning of objects. And so this gives you resilience from, mutations that are, bad. You want to be able to recover and roll back to a previous version. You can turn off deletion of versions as well to protect that. Another best practice in data protection would be, dealing with storage resiliency. So making sure that you have a resilient storage platform. So again, things like S3 built out to 11 nines, right? So that's pretty durable. You really don't have to worry about losing any data there. And, detailed logging goes along with this as well. So in the incident response, example of best practice there is, again, using that templated clean room strategy for doing the forensic analysis when there is a security event, right? So template out your environment in CloudFormation and use that to quickly spin it up so you can create a new trusted environment to conduct your investigation.
And again, that one sounds like big teams only type thing. But yeah, I don't know. Maybe the thing is when you do have a security incident, it kind of doesn't matter how big or small your team is. It's sort of all hands on deck, and that could be a great way to start to take a look at it.
Yeah, I mean, it's one of those things, where hopefully you never have to do this. And yeah, I mean, odds are, like, if you are employing this strategy, then you're a big enough company and team just to be able to support having these folks on board to be able to do this.
Exactly. All right. So those are the best practices, right? There weren't any others we were going to talk about for security.
No, I think you know what. Everyone, you can open your eyes. We've made it through security. Yeah.
Fantastic.
Just a sec. There's something important you need to do. You must have noticed that Mobycast is ad-free, but Chris and Jon need your help to make this work for everyone. Please help the Mobycast team by giving us 5 stars on iTunes, writing positive reviews, and telling your colleagues, friends, neighbors, children, and pets about the show. Go ahead and do it now. Great. I promise not to ask you to do that again.
So time to talk about reliability. I think we can get through a good part of this today, and then 2 more pillars next week.
Yeah.
So reliability, go for it.
So pillar 3 is reliability, right? So what is that? So reliability is the ability to recover from failures, to dynamically acquire resources to meet demand, and to mitigate disruptions, such as network issues, right? So this is again, a big, comprehensive swath of functionality that it's dealing with, right? So it's just everything that goes into having a workload that's always it's always available, right? And it's operating and people can use it in a timely fashion. So we're going to deal with failures. We're going to deal with scaling up and down, and we're going to be resilient to disruptions that shouldn't take us down completely, right? That we might do some graceful degradation.
Right, and reliability is so big that it kind of makes me feel like it makes me think about ilities in general. I'm not sure if you've heard that term as a computer term thrown around. Just ilities. Have you heard that?
Yeah, I mean, we talk about things like scalability, reliability,
maintainability. And it's like the ilities. Like reliability is probably one of it's the grandfather maybe of all the ilities. It's like sort of covers a lot of them, and maybe that's why they chose this one to be their pillar.
Yeah, I mean, it definitely covers a lot. I mean, when you say, and that's why, I mean, there's not the scalability pillar, right?
Right. Because
scalability is part of this reliability.
Exactly.
Reliability is even bigger than that.
Right.
And so, otherwise, if scalability was a pillar, we'd have more than 5. Yeah. So let's talk about design principles for reliability.
Sure.
Right. So one is to test your recovery procedures. Right.
Ooh.
So, which is it's a big one. I think it's one that a lot of people don't really do.
I think we just lost 999 out of 1,000 dev teams.
Yep. So definitely, this is one of the core principles. There is having recovery procedures and testing them.
Isn't that what AWS is for, though? Aren't they supposed to be the ones that test that?
Well, it depends on what's this kind of goes to the.
I mean, it's a bit of a joke, but I think, there starts to be that sort of attitude around managed services, right? Like, it's a managed service. They take care of that work.
For managed services, they are, for the most part, dealing with that. So if Lambda has a problem, right? Like, if they have to recover from a Lambda failure, like they're doing that, right? That's a fully managed service. Things like RDS, their managed application, they're semi-managed, right? It's not completely. So there's responsibility there on both sides. AWS is doing some stuff. They're responsible for the actual database, but you're responsible for the data.
Right.
So there's some back and forth there. And then of course, if you're self-hosting, right, then it's all on you. So another key design principle here is to auto recover from failures. Automate all the things, right? So same thing here. We want to, as much as we can, we want to automate whatever steps need to happen to recover from a failure. And this will go into, if you have really, well-defined run books and playbooks, that will feed into this as well.
Cool.
Another core principle, scale horizontally to increase availability. So, this was definitely, we talked about this in the 12-factor app, where it's all about, you're going to scale. You have these stateless processes, and you scale by just adding more processes. That's that horizontal scaling, right? So we're just going to keep adding these duplicate services that can do work, and they're all stateless.
Right. And speaking of ilities, that was one, availability.
Yep, indeed. Another one is stop guessing capacity. So this goes back to one of the we talked about this in last week's episode, that one of the overall design principles of the well-architected framework, and this is specifically in the reliability pillar as well, right? So this is all about, we talk about, as the definition of it, the dynamically acquiring resources to meet demand, right? And so that's kind of what this is, like, take advantage of all the services and features that in the cloud to allow you just to spin up, spin things down, go to that model where you're only paying for what it is that you need, and you don't need to over provision, or you don't need to run out of capacity unless you actually built that into your architecture erroneously, right?
Right. Well, but is it worth saying though that this doesn't necessarily mean that you have to be able to write a system that can scale from 5 users to 5 billion with one architecture, but rather that that your system can handle sort of scaling up and down for the maximum amount of workload that it can handle. So I'm thinking, for example, about you just may have a system that's built on a regular RDBMS database, and it can scale pretty big. But at a certain point, you're just going to need to add more. It's that flexible architecture that the well-architected framework is also talking about. You're going to have to add more components, certain kinds of caching, maybe other types of databases in order to be able to scale beyond a certain point. And it doesn't matter if you've built auto-scaling into it. There is going to be that place where it's, okay, this can't handle the load anymore. And that's not the same as not guessing capacity, but it is sort of similar, right? It's like, well, we'll build this to handle up to 100,000 users. And then after that, we're going to have to do something.
Mm-hmm. Yeah, and I mean, you can think of it as that, your workload's going to go through evolutions, and it's going to go through milestones, right? So you're going to have, you may have an MVP, and then V2, and V3, V4. And so each one of those may have a different architecture, right? Or you're going to make changes to the architecture. But for each one of those milestones, you're not guessing on capacity. Right? So that's the core thing that should be going on.
Cool.
And then last design principle is to manage your change with automation. So if you...
They put automation in twice.
Just automate as much as you can. So for the design principles here, we talked about auto recover from failures. This is to basically use automation to manage change as well, right? Yeah. So failures and change, basically just everything that can be automated, you want to automate it. Take people out of the equation, because people make mistakes, people forget. We're not good at doing those kinds of things. Right. Versus that's exactly what computers are good at.
And this is such a great business thing too. I mean, we talked about how this well-architected framework kind of reflects back into the business and not just the pure technology part of the, anyway, it's not just technology, right? So if you think about Amazon itself and how it became such a powerhouse, it is because of that automate all the things mindset. Like, as a bookseller, they started automating stuff, and then they had made so much cool automation technology that they started selling it. And they're just automating on top of that too. And it's like, if you want to build another Amazon, there's something to learn from that. Like, even as we sit around saying, well, some of this stuff is maybe a little too much to reach for a team with a lower budget, or a smaller team, or a team with certain kinds of risk tolerance because they're trying to grow fast or something. Maybe they don't have all the time to worry about game day type activities. But that one thing, to automate all the things, like any team can have that mindset, and that can lead to amazing growth.
Yeah, absolutely. And it's also those are investments that end up usually paying off at some point, right?
Exactly.
So again, it may be something that manually it takes you 1 hour a week to do, versus to automate it might take 20 hours. But after 20 weeks, it's now free, right? You're now getting back time.
Exactly.
Right. And so now that's a win. And so you start doing those things consistently, and you really get the network effect.
Exactly.
Yep. So key service for reliability, that would be CloudWatch. So CloudWatch is going to give us insight into exactly what's going on in the system. It's going to be giving us events for when certain conditions are reached and whatnot. So it's going to help us scale our capacity. It's going to tell us when latency is too high and we need to deal with that. So CloudWatch is going to be just a core service here in the reliability pillar.
And it also will be the cloud's version of cron, so it can schedule things to happen that maybe should be happening, when the system's not busy. All kinds of great stuff in CloudWatch.
Mm-hmm. Yeah, you have to, hats off to CloudWatch. It's pretty amazing just if you think about like what it has to do, it's a really complicated, hard problem, and it's so key to just about everything. If CloudWatch, if there's any problems with that, like just everything breaks. So, just the cron job part of it, right? Just having scheduled events, scheduled CloudWatch events, just that problem alone, like that's for the number of events that it's dealing with, and then each of those schedules, just that alone, like is trying to build a service to do that, right? That's a pretty monumental task, and that's just a small slice of what CloudWatch does.
Yeah, no, it's one of the most impressive services. Once you get to know it, at first it's sort of like, wait, this feels like crappy for a logger, but that's not all it is.
Yeah. Well, don't get me started on CloudWatch logs. So focus areas, 3 focus areas here. So foundations, change management, and failure management. So this is, again, kind of one of those like head scratchers. It's like, so we're in the reliability pillar, and 3 focus areas, and they're foundations, change management, and failure management. And
I can see failure management, right? That makes sense. In order to be reliable, you got to make sure you're managing failures. And it's a focus, right? There's other ways to being reliable. Change management, that feels like just like AWS, like, oh man, remember that one time where we had a bad configuration and we blew out one of our regions? So that's probably what that's about, right? Because they made a change to a configuration and totally brought down a region. And then foundations, I don't know what that is. It doesn't really speak to me.
Yeah. So it's just, when I came across these, I was just like, this is kind of surprising, for given that it's the reliability pillar. It feels like it's almost like not enough surface area being covered by these 3 things. But that said, you could say foundations ends up like that covers just about everything, right? That's not either change or failure.
Right. So and reliability is kind of responsible for the ever increasing cost of software too, right? Like I often talk about how the software expectations just go higher and higher. So like, building a website is not just as easy as like throwing out some HTML and being like, look, here's my website. It's like so much more goes into it, and the tools get harder. Like React.js that's not an easy thing to learn. You don't learn it in an afternoon. So why are these tools so hard? And I think a lot of it comes back to this reliability piece, especially for back-end developers. Like it's just a black eye for anybody now to have a site go down or to have a service go down or to have a very visible error. And so that all kind of comes into reliability, or to have a deployment or to have a release that just fails, like, and then to automate recovery of that and to limit blast radius. Those are all expected things now. They're not like, oh yeah, everybody makes mistakes. It's like, no, a lot of companies don't really make mistakes anymore. So which kind of company are you going to be? One that doesn't make mistakes or one that does? Yeah. So it gets harder. Expectations get higher. Software gets more expensive.
Yeah, indeed. Yeah, so maybe we can talk a little bit about some of the core AWS services for each one of these focus areas. So with foundations, some of those services are going to be things like IAM, VPC, Trusted Advisor. And Trusted Advisor is because of its visibility into service limits. So service limits are going to be pretty important. from
Yeah.
from a foundational standpoint, right?
Yeah, they will. Yeah, you can bring down a system if you're not paying attention. Yeah.
Mm-hmm. And then Shield. Again, we talked about that previously. So this is going to protect you against things like distributed denial of service attacks. For change management, things like CloudTrail, AWS Config for sure. So for those people that are not familiar with AWS Config, that's a way for you to track the state of your system, and then any changes that happen to that state, get events on that. So really
does
good.
CloudFormation use that as a dependent service? Because I noticed that CloudFormation tracks drift. Is that using AWS Config?
I don't know for sure. I wouldn't be surprised either way if CloudFormation has its own way of doing it, and Config is a whole different way. But yeah, they have drift detection, right?
Drift being, this is what you made, and now it's changed. You've added a new instance, you've changed your IAM policies. Like, that's drift.
Yeah, anything being managed by CloudFormation, if it's not configured that way in your environment, then that's drift.
Cool.
And then CloudWatch is definitely part of this change management, and auto scaling, right? So change management, and this is like the scaling up and down to meet demand, right? So that's considered part of the change management focus area.
Makes sense.
For failure management, things like CloudFormation, S3, Glacier. And so, yeah, the reason here for failure management is basically backup and NTR strategies, right? So S3 is for backups, and then Glacier is for archives. So it's all about, that having those copies of the data, being able to recover when failures happen, right? Yeah. So let's talk about some best practices. So in the foundations focus area, talked about this a bit before, but take into account your physical and service limits for your workload, right? So this is both at like the network level, understanding things like CIDR ranges and how many IPs you have, and dealing with like service limits, both like from a how many API requests you can make for a certain time period, or other infrastructure limits like load balancers, like how many load balancers can you have in an account or region type thing. So just really making sure that you've thought that stuff through, and you're not putting up any brick walls as your system evolves. Another best practice in the foundations is to really think about high availability, and what does that mean to your workload, and how are you going to architect it to have high availability, right? So this is a big topic, and there's lots of questions here to ask yourself and things to think about. But some of the major things to think about would be like making sure you don't have any single points of failure, right? That would be a big problem, right? If you have a SPOF, you want to be making sure that you have a multi availability zone design, right? So you don't want to be just in one AZ, right? You want to be at least 2 and probably 3. You want to take advantage of things like load balancing. You want to take advantage of auto scaling. If you have a hybrid environment or VPNs or whatnot, you're going to want to be thinking about redundant connectivity. So if you're direct connect, you want to make sure you have redundancy on that. Same thing goes with VPNs and any other kind of networking you may have. And another big open area is software resilience. So this goes to our applications, right? Like making our applications more resilient. And that's just a wide open field. And we covered probably like at least 4 or 5 of the principles of the 12-factor app, right? All are underneath this concept of software resilience.
Right.
So
I wanted to mention that the availability stuff, a lot of it kind of comes for free with typical web applications when you're using the cloud. Like, it's not that hard to do it, right? Like, if you just if you're using the console to set up your database, you just click the right thing and boom, you got some high availability database. Or like you're using an ECS, like you just choose to have more than one node run in your containers and you got high availability. And like a lot of that stuff is super easy with the cloud. Like it's like almost harder to get it wrong, and that's on purpose, right? And you mentioned like if you're running a hybrid environment, that's when you got to think about like having additional ways of more than one way to have internet connectivity. And that got me thinking about some of our own projects and just like in particular IoT. And it's like whenever I'm thinking about availability and connectivity, it's often because I'm worried about little IoT things like little devices that are here and there and trying to send data to AWS. That's when I've gotten wrapped around the axle in recent years when it comes to availability and dealing with it. Because the cloud takes care of so much of the other stuff.
Yeah, I mean, there's no doubt. We build mobile apps too, right? So like building mobile apps that actually still do the right thing when they're transferring between cell towers, right? Yeah. And they lose coverage, right? And they go off of Wi-Fi to LTE. So what happens? People go into airplane mode, right? So it's definitely
it seems like that's where that's where some of the hard thinking about that stuff happens now, more so than as long as you just follow some best practices around not having single point of failures in the cloud, the rest of the cloud available, and then like writing good software, like actually having applications that don't fall over because of their own bad code, then the availability problem takes care of itself in the cloud.
Yeah, I mean, I definitely agree with you. Like the cloud makes it like a lot easier to have a workload that has high availability. But that said, it's still not easy. And I would bet that the majority of workloads in the cloud do not have like these basic characteristics, all of them, right? So there are architectures out there that have single points of failure. There are architectures out there that they're not multi-AZ, right? It's all on a single AZ. There are ones that are not doing auto scaling, like, or they're very least they're not scaling up and down automatically, right? It's a manual thing. And then obviously in software resilience, like, being able to, having services thrash and crash. I mean, even silly things like session state, right? Like still trips people up. So, it's kind of easy to like take all this stuff for granted and say like, it's kind of easy to build a high availability system. But I think, in practice, like I think people still find it challenging. All right. So continuing best practices in the failure management focus area. Things here are just backup and disaster recovery, right? Having those plans. Thinking about your RPO, which is your recovery point objective, and your RTO, which is your recovery time objective, like understanding what those are and what you're designing for. You should be thinking about that. So recovery point objective is really just saying like, what is the increment of data that you can afford to lose, right? So you might say like, we have to have data within the last like 30 minutes. That's as much as we're willing to lose, or it could be 5 minutes, right? But that's your recovery point objective. And then your recovery time objective is how long it's going to take you to recover when this does go bad, right? And so, if you have backups on S3, then it's like how long it's going to take to, detect the failure, get the appropriate backup, and then get that backup restored. And that would be your time, your RTO, your recovery time objective. And that might be different if your backups are actually archived to Glacier or something like that. So keep those things in mind. Have your disaster recovery plan in place, and then obviously you want to have game days and practice going through those kinds of processes.
Very cool.
Yeah. And then another thing, best practice in failure management is, inject failures into your system to test resiliency.
Yeah.
So this is basically chaos engineering. And you can go crazy with it. It's pretty sophisticated. It's not really new anymore, right? It's been around, like the concept has been around for 5+ years, especially thanks to Netflix and its Simian army. Definitely as a best practice, like this is what we can aspire to do.
Yeah, I like it. Every time I hear about it, it's like I want to do it. And I'll admit we haven't done it yet. But it seems fun. It seems like a fun coding challenge to play with and overcome some of the things that chaos type testing could result in.
Mm-hmm. Yeah, I mean, it's like it really doesn't make sense to do it until you've done you've got the fundamentals down, right? You have to be able to recover from failures automatically.
Right. Yeah.
You have to have software that's resilient to these things. Otherwise, if you don't have that stuff in place, then inject failures all you want. It's just going to crash the whole thing, right? Yeah. It's not going to be too terribly useful.
Right.
You have to have built this thing out with the idea that failures are going to happen, and this thing will continue to run when these failures do happen.
Mm-hmm.
Cool. So to wrap this up with reliability, we can just talk about maybe some of the key points to keep top of mind. So one is, plan your network topology, right? So again, think that through. Don't design yourself into a box, right? By creating one subnet with the entire 64K address space. Think carefully about your CIDRs. Make sure, if you're gonna be having peered VPCs or other networks like hybrid networks and on-prem networks, that you don't have collisions between your subnets. So just plan your network topology, because it is really it's important, and it could turn out to become really important down the road. And it's definitely one of the first things that you do. So
if you're planning a network topology, I mean, we don't really have time to get all the way into this, but maybe there's a little rule of thumb that would be easy for people. I think it would be safe to say it's easier to grow a subnet than it is to shrink it. So maybe, think of it from that perspective. There's a limited IP address space. You don't want collisions. You don't want to run out of IP addresses. But if you give yourself 16 or 24 or 32 IP addresses and you discover you need 35, that's not a hard change to make.
It depends on a lot of things, right? It just depends on everything else and how you defined it, or, what's the interrelationship between these things, what you're putting on the subnets. Ideally you just want to right size them, and you don't want to have to change them. So
I'm sitting here going, wait a minute though, that's so against the well-architected framework rules. Didn't we say at the very beginning that we don't want to guess at capacity needs? Literally, that is a tenet. It's so funny that it's wait, but actually make sure you have enough IP addresses.
Well, this is a little bit different, right? Because this is your network topology. And so your network is not going to scale up and down elastically, right? It just doesn't work that way.
But it does. Isn't that computers? And computers, don't they use an IP address? And wait, now you need to know how many computers you're going to need.
Right, but you have things like your mask, right? Your CIDR address space, right? So, and that's kind of a fixed thing, and you can't. Sometimes you can't even change that, right? You can't. I guess an example would be if you're in a VPC, if you make a subnet too big, well, then you're kind of hosed. You can't add any more addresses. You can't add any more subnets because you just don't. The space is being taken up by the other one.
And that was where I was going with my original comment. Make them small, and then it's easy. You can increase their size later if you have to.
Yeah, just as long as there's the. Again, I think there's a bunch of different factors that go into play there. I think it's kind of easy, right? To think you can think of it your network topology in the form of building blocks. So it's okay to. There's some size to a subnet that makes sense to you, and it could be it's a subnet that's 256 IPs, and that's a good building block size, and or it could be 512, or it could be a K or something like that. But probably shouldn't. It shouldn't be like 32K. Like putting 32K addresses on a subnet doesn't make a lot of sense. And likewise, 16 is probably too small. And same thing with 32 and even 64. So,
so maybe the thing is, use some other companies' way of doing it. Like think about it the way some other company does. Like AWS has a thing where they kind of limit any network to any subnet to 5,000 IPs to limit blast radius. So like if you need more than 5,000, then that's another deployment, right? And then the deployments may need to talk to each other like through some other system, like network to network type communication. But then that's a bigger architecture, right? So you're not like, oh, I need to be able to scale from 1 to 100,000 machines in this like horizontal scale out that I'm doing. No, it's like I'm going to scale from 1 to 5,000, and then I'm going to scale again. I'm going to make another one, and it's going to scale from 1 to 5,000. Then I'm going to make another one, and it's going to scale from 1 to 5,000. And that way, you can kind of meet the tenant, because that's what I was sort of joking about. Like, okay, you're not guessing at capacity needs. You're just setting up something that's able to scale, and then also a network that can kind of handle scaling again and again and again and again as needed.
Mm-hmm. Yeah. So it's not this kind of elastic principle that we're kind of used to with things like compute and storage and whatnot, but you can think of it as just building blocks, and it's really easy to add on these additional blocks as you need them. And there's the takeaway here is just think it through, like understand like what those trade-offs are, understand like what limitations you might be putting in at the very beginning, just by when you're setting up your VPC, right? Mm-hmm. Like there's been many people that have been burned by that, right? When they set up their VPC, then find out down the road is like, oh no. Mm-hmm. I have to go create another VPC.
Right. And VPCs really are the root of all evil when it comes to AWS, because not only do they catch those people that you just mentioned, but you're trying to have a podcast and keep it to 40 minutes, and then you start talking about VPCs, and boom, you just blew out the podcast.
Yeah, indeed. So moving on. Some other key points. Just make sure you manage your AWS service and rate limits. So know what those are. Again, make sure you're not putting up any artificial walls that are gonna block you as you grow. Monitor your system. So get CloudWatch, instrumental here. Just really know what's going on in your system, so when you do have to scale up or when you have to scale down. Know when things are failing. Know when things change. Yep. Automate your responses to demand. So again, take advantage of those services, those features that will provide that elasticity, so use auto scaling, have the scale up, the scale down events, use some of the managed services where it makes sense that just have basically infinite scalability. So Lambda, look at things like Fargate, DynamoDB. All these things really help with that, so that you don't have to manually deal with demand. And then, final one with, obvious backup. Right. So, you're not going to deal well with failures if you're not backing up. So backup, restore, disaster recovery, keep all that top of mind and have plans for it and practice.
Good. All right. 2 more pillars down. So we've made it through operational excellence, security, and reliability. We've got 2 more to go next week.
We do.
Looking forward to it.
All right. Sounds good.
So much for this week's education, Chris. Talk to you next week.
All right. Thanks. See ya.
Nobody listens to podcast outros. Why are you still here? Oh, that's right. It's the outro song. Come talk to us at mobycast.fm or on Reddit at r/Mobycast.